Hey students, it's Mrs. T, and in this lecture we're going to talk about the landforms that make up the body of the Earth. We have focused so much of this semester on the atmosphere, atmospheric structure, flow, movement, solar energy, the fluvial process, biomes, the surface of the Earth we've focused on a lot. And now we're going to look toward the internal structure of the Earth. And so chapter 13 in your textbook is what we're going to focus on, and it is a very introductory chapter that leads us to the following more in-depth views of each of these things. So there's a wide variety of topics that's covered in chapter 13. One of them is the interior structure of the Earth. You see the image behind me on the screen. We're going to cover that in just a second. You're also going to look at the mineral content of the Earth. It's a very, minerals are a very important aspect of the composition of the Earth. They affect not only the types of rocks, which we'll look into, but also the way that seismic waves during earthquakes and plate tectonic movement, it affects the way that those things move. It affects the magnetism of the Earth and all the convection inside the Earth, because you can think of the Earth, even though we have solid structures in the Earth, you can still think of it as a fluid thing where convection moves objects, moves masses of stuff within the Earth. We'll look at that particularly in the core, where we have molten lava or magma that has convective cells in it. And so these are the kinds of topics that we're going to cover. And we've had just a bare bones elementary reference to plate tectonics already when we were learning about the Wallace line in Asia and between Australia and Asia, and the animals, how the animals are completely different from one side of the line to the next. And one of the theories that Alfred Russel Wallace proposed was, even though we didn't call it plate tectonics at the time, was that the Earth's crust had moved. And so I've used the word crust, and so let's go ahead and get into this image that's behind me. I've got a lot of different graphics for us to go through in this introductory conversation. Okay, so this is a very, very elementary kind of cartoon image that I have behind me to show you the different parts of the Earth. You've probably seen an image like this in your earth science textbook. There's certainly one in our textbook in this chapter, but you've probably seen this before this point, and you probably are aware that just like our atmosphere that has different layers in it that we've covered earlier in the semester, the Earth has different layers. And what we're standing on, sitting on, whatever, right now is the crust of the Earth. And the crust is the outermost layer that is not smooth like this. You see on this image back here, it's all pretty and smooth. The crust is not smooth like this. The crust is above water and it's below water. The oceans sit on a portion of the Earth's crust. Let me see. I've got another image in here. Not that one. Not that one. Let's see. So let me find the other image that I want to show you. I think it's here. No, not that one. Where is it? Okay, this one is the one that we'll use. Okay, so in the outer crust, you can see this one is much more representative. It's not a cross section completely. It's like a chunk that's taken out of the Earth. And so you can see that the lithosphere is this top area here where we have continental crust and ocean crust. But I switched over to this image so that you can see with me what I've just referenced, that oceanic crust and continental crust. So the continental crust is what we're standing on right now. It's above sea level. It goes down, all the way to the top of the mantle, the outer, and borders with the outer mantle. But the oceanic crust is much thinner. You can see over here where this water is represented, it's a much thinner piece of the lithosphere than continental crust. It's denser also. It's heavier rocks. There's more pressure because you have more atmospheres of pressure on it because of the water on top of all the air atmosphere layers that are putting pressure on the Earth and gravity pulling, of course. And so we have a variety of thicknesses of minerals that are made up in this in the lithosphere, and there's a lot of different activity that's happening. So this picture that I happen to have is a subduction zone. Subduction is a movement of one piece of crust underneath another. So you can see that this ocean trench has been formed because this part of the lithosphere is being forced down underneath the other into a hotter, more pressure-filled area of the Earth. And we know from studying the atmosphere that temperature and pressure and density work together to create force and to create motion. And that's why you see these magma chambers depicted in this graphic. These magma chambers where elements of the solid uppermost mantle or the oceanic crust are melted. These things are melted, and then these little chambers, these channels, filter up. The heat filters up through the continental crust and creates these volcanic ridges across the Earth. Mountains are formed this way. Ridges underneath the ocean. This particular trench, like the Mariana Trench you might have heard of before. You can research it and look to see how long it is and what kind of internal forces have created the Mariana Trench over time. But the oceanic trench that you see here is one type of formation on the bottom of the ocean, but you have mountains on the bottom of the ocean also. And so these things are caused by different kinds of slip zones or contact zones within the continental crust, within the upper mantle, and they cause all kinds of topography and land masses that we become familiar with on the globe. And so you've recently looked at the Mississippi River drainage basin, and you've looked at things like the Appalachian Mountains that form, some of the continental divide where the groundwater flows over those masses down into the tributaries of the Mississippi and then down toward the Gulf of Mexico, or the Rocky Mountains, for instance, or another place where you have that gravity force bringing groundwater down toward those tributaries and then down into the Mississippi River, the Arkansas River first in some cases, the Missouri River down to the Mississippi and down into the Gulf of Mexico. And so these different areas that we're familiar with, that we can see on the map, that we can see the topography, we can study the surface of the Earth. These things are created over time by powerful forces within the Earth that are constantly moving and regenerating and recycling and absorbing and releasing energy. And that's why we have the variety of land forms on Earth that we do, because this planet of ours is alive. It's got minerals in it that are interacting with the pressure and the heat, and they create different densities. And these things can be found on the surface of the Earth, like you go to the Crater of Diamonds State Park in Arkansas and search for diamonds on the surface of the Earth. These things are diamonds because of the pressure that was applied to them over time, and minerals change states. They change forms when you add pressure or when you add heat, when you add those elements to an existing material. It can morph, it can change into something else. And so we're going to look at the different types of rocks. I'm getting a little too deep into some of these lessons that I already have curated for you in other places. Let me go to another. Yes, okay, so this is a different type of section of the Earth where you can see how seismic waves that we're going to look at. By the way, I've got another graphic for that. Just like there's waves and circulation and motion in the atmosphere, you can use the same physics that you use atmospheric physics apply to the Earth also. And these different waves of, this P wave, think of it as like a slinky. Have you ever had a slinky and you leave it on the ground in front of you, and it's all pushed together, but then you can pull part of it away and it stays pushed together, and you pull part of it away. This is what how a P wave runs through the body, or the crust of the earth. There is also something called the moho discontinuity. Where is there we go, back to my graphic here. And this is a layer of a significant change at the base of the continental crust that borders the uppermost part of the mantle, and there's a mineral change, there's a density change, and it affects the way that seismic waves run through it. And so there are an infinite number of ways that you can study the earth. If you're a chemistry person, a physical geology person, a physics person, you can study the earth in so many different ways, because there's minerals, there's processes, there's motion, there's heat, there's pressure, there's density. All of these different components make up the ground that we're standing on right now. I mean, I'm getting amped up because I'm drinking my coffee here, but underneath the earth right now, there are so many processes and so much pressure and so much motion going on that we cannot sense it with our own feet, with our own eyes. We can study the internal earth because of some of the remote sensing tools that we have. We learned about way back in chapter 1. Some of the remote sensing has given us a lot of information about the structure of the interior of the earth, and how we are a planet that's constantly regenerating itself, releasing and absorbing and regenerating and recycling. And so those are the topics that we're going to look at from now until the end of the semester. This particular chapter gives you an overview of all of them, and so some of the curated videos that I have for you gives you the animations that are going to make some of this real for you, and you're going to learn about mineral compounds in the earth and where those minerals came from, and plate tectonics, and I think you're going to enjoy these topics as we finish out the semester. So I look forward to your reflection journals, and of course we have our typical quizzes, and please text me with any questions that you might have. I'll see you in the next video. Bye.